Cardiac cycle. The cardiac cycle involves atrial and ventricular systole, contraction, and diastole, relaxation. Diastole allows the chambers of the heart to fill with blood, and systole allows blood to be pushed into another chamber of the heart or into a blood vessel. During systole, pressures rise in the contracting chambers, and during diastole, pressures will initially drop. Since blood flows from an area of higher pressure towards an area of lower pressure, down a pressure gradient, the sequences of atrial and ventricular systole and diastole, and the pressure differences created will determine blood flow. During the cardiac cycle, the valves of the heart help direct blood flow from the right side of the heart towards the lungs and from the left side of the heart into the systemic circulation. The closure of the valves during a cardiac cycle produce the typical lub-dub heart sounds. You've already reviewed the basic sequence of blood flow, as well as the electrical and contractive functioning of the heart. It's time to put the pieces together. The cardiac cycle takes 800 milliseconds and a heart beating at 75 beats per minute. It involves the following phases. Number 1, atrial systole. Number 2, ventricular systole, which includes isovolumetric contraction and ventricular ejection. Number 3, relaxation period, which includes isovolumetric relaxation as well as ventricular filling. We will begin with all the chambers of the heart and diastole relaxing to demonstrate the events leading into the beginning of a new cardiac cycle. Venous blood returns to the right side of the heart via the right atrium. At the same time, blood returns to the left side of the heart via the right and left pulmonary veins into the left atrium. Blood passively fills the ventricles bilaterally as it flows from their respective atrium. We start a new cycle. Atrial systole, approximately 100 milliseconds. The atria contract, pushing approximately 40 milliliters of blood from each atrium into their respective relaxing ventricles, adding to the final volume collected in each ventricle during ventricular diastole. The final volume collected in each ventricle is called the end-diastolic volume, approximately 130 milliliters. Remember, the ventricles were already filling with blood passively prior to atrial systole. The pressure rises in the ventricles. Following atrial systole, the atria then enter diastole for the rest of the cardiac cycle. Ventricular contraction, systole, 300 milliseconds. As the ventricles begin to contract in isovolumetric contraction, the increased ventricular pressure results in the closure of the AV or atrioventricular valves, the tricuspid and the bicuspid valves, resulting in the first heart sound, S1, also known as lub. This portion of ventricular systole is approximately 50 milliseconds in duration. Note that blood is not being forced out of the ventricles just yet, but the pressure is rising. At the left ventricle, pressure greater than 80 millimeters of mercury will open the aortic valve, and at the right ventricle, a pressure greater than 10 millimeters of mercury will open up the pulmonary valve. Once the pressure in the right ventricle is greater than in the pulmonary trunk, and the pressure in the left ventricle is greater than in the aorta, the pulmonary and aortic semilunar valves are forced open and blood is pushed forward in the ventricular ejection phase of ventricular contraction, approximately 200 to 250 milliseconds in duration. Blood is forced into the pulmonary trunk from the right ventricle and the aorta from the left ventricle. The left ventricular pressure rises to 120 millimeters of mercury, and the right ventricular pressure rises to 25 to 30 millimeters of mercury. Approximately 70 mLs from each ventricle will be ejected. This volume is known as stroke volume. The remaining 60 milliliters in each ventricle is known as the end systolic volume. Relaxation period, 400 milliseconds. As the ventricles begin to relax, ventricular diastole, the pressure in them begins to drop. When the pressure inside the ventricles is lower than the pulmonary trunk and in the aorta, blood begins to flow down the pressure gradients towards the ventricles. But the closure of the pulmonary and aortic semilunar valves prevents the backflow of blood. The closure of the aortic and semilunar valves results in the second heart sound, S2, the dub. During the isovolumetric relaxation phase, all the heart valves are closed. During ventricular contraction, the relaxing atria were still receiving blood. With ventricular relaxation, we will see the pressures in the ventricles drop below the pressures of the atria, resulting in the opening of the AV, tricuspid, and bicuspid valves. With the AV valves open, blood will again flow passively into the ventricles bilaterally from a higher pressure to a lower pressure. This phase is known as the ventricular filling phase of ventricular relaxation. A new cardiac cycle will follow.